Welcome to another CO2 Monday in the Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and thank you so much for taking the time to come and hang out with us each week, continuing to grow our knowledge, get better at what we do, and just really develop our skills because this is what it's all about, sharing knowledge and getting ourselves to the next level. I've been talking with so many CO2 experts from around the world, learning from them. And this week, I have another CO2 expert who's been in the refrigeration industry for over 10 years, work with some of the major contractors in the UK, and now is heading up the technical department. A good friend of mine, company James Bailey, Omega Solutions, and I'm super excited to get into this because Chris is the guy who has been in the trenches. He was working on CO2, then got into the design of it, which is real cool because this is what I talk about with technicians all around the world. You know, doing service install is great, but when you start to learn the design, that's when the game changes. That's when you really start to develop your troubleshooting skills. Chris, welcome to CO2 Monday. How you doing, brother?
Very well, thank you for that introduction, Trevor. So it's nice to hear the nice things to say about the industry as well. CO2 is definitely the way forward, I think, in a lot of applications. There's a few which is not quite there yet, but I think the more people get used to it, the more they're going to realize it is the future at the end of the day. So
Oh yeah, for
yeah.
sure. Why don't you dive in a little bit about your story? I know you started around 2011 in this industry, but I'd love to hear because we haven't really delved into what you've been doing over the last 10, 15 years in CO2.
Yeah, I mean it's a big change. So I started a very small contracting company, actually my dad's company. I mean, he started in 1983, so
Oh wow.
yeah, 40 years ago this year. So that's basically his third child. There's me, my brother, and Cotswold Vale Refrigeration's company name. Very small contracting company, maximum of I think 8 or 9 employees at one point. So I trained up very old school apprenticeship on the tools, and you had to learn everything. It's not you're a service engineer, you're an installer, you're everything.
Yeah.
I was lucky when I was brought on board to be paired with a really top quality, really eager engineer, installer, trained up at another company, came to ours and fantastic pipe fitter, but he was also learning the ropes with service. So I was learning alongside him, which was fantastic. It's the best way to learn is by, as you said, getting in the trenches, getting your hands dirty, whether it's sweeping the floor, pulling cables in, terminating them, whether it's pipe fitting, brazing, bending pipe with old school skull benders rather than hydraulics. You learn everything start to finish, and that's what I absolutely loved. When I started, obviously CO2 was still, I mean, didn't even realize it was had potential as a refrigerant until I started. It came another 5 years as such. I think the largest pack I probably worked on at my dad's company was 20 kilowatts, a 2 scroll compressor pack,
Yep.
basically a glorified condensing unit.
Yep.
But the more exposure you get, the more you start to realize, oh, there's more stuff out there. And that's what grew my interest on the design side. And eventually, my dad said, go off and learn a bit more. And I was at university at the time, part time, 1 day a week, with a good friend of mine, Connor Eaton Smith. Very technical man. I try and get him on the podcast at some point. He'd be fantastic.
Yeah, connecting.
And he said, the EPTA group had some openings going as a design engineer. I was like, well, what's the worst that can happen? Applied there, and they took me on, gave me loads of training. They have a CO2 training school up in Bradford in the UK. Really knowledgeable people running that. That was my first real exposure to CO2 hands-on, and it was such a good course. Only a 2 day course, but it was enough. It was another 3 years as such before I actually laid hands-on again on the tools to work on a CO2 pack. And that training was enough to actually get me through it. I was scared. First time exposed to CO2 for, on the tools since that training course. But yeah, it was enough to get you through it. And I think that's what really makes the fact about training and competencies such an important part for the industry. The more we can train people, the better it's going to be at the end of the day.
Okay, so you started with the EPTA group. So the first 2 years you were working with them, learning them, not working really on CO2, took their training, but after about 2 to 3 years in, that's when you started to get service calls on CO2 stores or install. Like what were you doing? Install, service,
So as
or
as
just
a
design?
design and applications engineer, I was working on CO2 from day one.
Okay.
We got to a point, obviously, the industry is so busy. You get times of year where there's no one available to do any. You've got an emergency call or a pack swap which needs to happen,
Yeah.
and you rope in whoever you can. And I've got a garage full of tools still. I was like, I'll have a go. What's the worst that can happen? I've got plenty of people on the other end of a phone. I can ring them if need be. And yeah, I think it was about this time 3 years ago, probably mid-November, early December. Do some cold room extensions for a retailer, convenience store, budget retailer, and yeah, we got through it.
Yeah. No, that's fair.
It's
So,
a
so
bit
you
worrying
start
at
out,
times.
you're second generation, you're working with your dad, probably working when you were even in grade school, high school. Come on out, you're
Yeah,
doing service calls because this is what I hear about second generation. It's just this is it. You're in it, right? And then you went to school, and did you go to engineering? Did you go for mechanical engineering? What did you do at university? Then you get to EPTA. Like, how did you make that transition from doing service
yeah.
work into application engineering?
So it's a funny setup in the UK. We have what would probably be the equivalent of first, I think it's up to the first 2 years of high school in America. So when you're 16, you have a choice of going off to what we call college, which is effectively the last 2 years of high school in the UK, in the US, where I actually did subjects were not related to engineering whatsoever. I had no ambitions to go into the refrigeration industry, especially after watching my dad for 16 years get called out on weekends and nights and answer the phone every hour of the day. But it came to the end of my college and I didn't really still know what to do. And he said, basically, why don't you come and help out, earn some pocket money over the summer until you realize what you want to do. And yeah, from day one, I was absolutely hooked. So I did that. And then in the UK, the bare minimum is a level 2 qualification, which would be, I don't know what that equates to over in the US and Canada, but it's about a 2 year course, 1 day a week. It's bare competence.
Yep.
Basics you need to safely work on a system. And then from that, you learn a little bit about the design in terms of heat load calculations. But I always wanted to learn a bit more about pipe sizing, how the fluid works inside the system, which the answers aren't readily available. And again, with the support of my dad and the rest of them at Cotswold Vale Refrigeration, they said, yeah, go off, learn. We do a higher national certificate, which then leads into a higher national diploma, which then leads into a bachelor's degree. It's 5 years part-time. It's a long, hard investment because even though you have a day's attendance at a college, trade school, the actual normal work doesn't stop, does it? You just end up picking it up in the evenings or on weekends. And then alongside that, you have the other work to do at the same time. So working through that, you end up doing these qualifications and basically just trying to improve and learn a bit more. And then slightly disappointed, all those 5 years, we never touched on refrigeration any more in depth than we did in our level 2 qualification in terms of calculating coefficient of performance, pressure enthalpy diagrams. It was a bit of a come down on it. Everything else you learn, though, is, I think that's where the real importance lies. It's managing the construction process, it's health and safety, it's contracts management, it's everything around the trade that you don't quite appreciate sometimes when you first start out. But yeah, there's always that drive to learn a bit more technical knowledge. And then again, as I progressed through, the only way I really found that out was not by going to official courses, it's just by asking people. It's finding really good mentors out there in the industry and picking their brains. So for example, at the EPTA group, I had a fantastic manager there, Ian Hardy. He's the most technical person I think I've ever met. He knows controls, he knows service, he knows install. And I worked very closely alongside him for 2 years, almost over the last years until I joined Amiga. But yeah, basically every day, just pick his brains, absorb his information and just deposit it in here. And hopefully something doesn't pop out the other side, which is also important. So that's the main thing I've found is just absorbing knowledge from other people.
And I definitely seen that too here. And this is really why I started Refrigeration Mentor for continuing education and developing people, because there was just none of that. Like, you go to school and then a lot of the times it's a lot of repetitive, the same thing, which you need, but there was not that next level of that technical training. And this is really why I've developed this for technicians that were in your position. You go to school for 4 or 5 years, but sometimes you come out and it's not really what the contractor even needs sometimes, because I get the calls from them, and you probably could agree with me, is that after you got 4 or 5 years, if you didn't do all those service calls, if you didn't do all those on calls, you know what I mean, you probably wouldn't have the skill. So if you're not in the trenches all the time learning the control side, the mechanical side, it's going to be tough from school to get out there, because I've seen this where technicians just change belts or flip filters or just washing out cases for 2 or 3 years. They just go in and do drains and condensers, but they're not getting that technical stuff. You don't really get enough of that in school. So continuing education is so important. And you got to have a little bit of drive, which you had.
Definitely. I mean, again, looking at your videos and listening to your podcast on episode 160, 169, is it now?
There's quite a few of them.
It's getting up there. The stuff you're covering, for example, oil management systems. We never covered oil management issues ever in my actual formal qualification. And funny enough, earlier today, I delivered 2-hour lecture, well, not lectures, tutorials for some university students, some who are part-time engineering in the industry, and some who are full-time joint architecture engineering students. So complete opposite ends of the spectrum. But in both groups, I got asked, looking at heat pumps, what maintenance issues are there? What would that cost? Why would you go for this versus, for example, an air source heat pump versus a ground source heat pump? And maintenance-wise, yeah, I said, for example, suction pipe sizing. You don't want it too small, you don't want it too big. Why is that? Oil management, oil return. But again, it's not really out there in literature other than it says must consider oil return. Until you start asking people what issues they found on site, it really then starts to drill into you and you learn from other people's experience. I think that's the most important part. I imagine it's the exact same over on continental, North America as it is over here. We have far too few technicians for how much work there is out there. Yeah. And with the technologies developing at such a rapid pace, trying to keep up with them is just unbelievably difficult. Tenacity some people are going to have to keep that skill set improving is worrying, but it's also quite, I'm not sure I've got the right word for it, but inspiring that people are actually still out there trying to learn it.
Yeah, no, I just had a conversation earlier today actually with a company in Italy that they're having the exact same problem that they're having in the UK, in the US. I'm going to crack this code and I'm going to become a billionaire from it probably. But it's like, the thing is that like we're losing lots of people out to other industries because of the on-calls, because of the after hours, and then the new technology, which a lot of people it is new and it is advanced, a lot of it. But when you dive into some training courses and you go work on CO2, it's just refrigeration. And it's way more funner working on CO2 than working on HFCs, hands down. It's so much more fun. Anyway, so let's talk a little bit about that. Like when you were working on all the HFC systems or even A2Ls or whatever, and then you moved into CO2, what was that shift and how did that feel? Because I know at first you said already that it was like intimidating, there was some fear in there, but what was that shift when you're like, man, CO2 is going places, like you said earlier?
I was lucky because when I joined the Apta group, my first real project was with this. It was with Aldi as a supermarket, and they're really at the forefront of pushing heat recovery systems on their sites. So I was straight away not quite thrown in the deep end, but I was instantly looking at false load coils on heat pumps on refrigeration systems. And then also, you've chucked a plate heat exchanger in there to serve the store heating. Is that serving fan coil units? Is it feeding wet fluid cassettes, or is it serving underfloor heating? What control strategies are there for those? And then after a few years, they've now gone down the route of having propane heat pumps, but with a CO2 pack as the base load heat. And also until all the heat can be taken out of that, it does not turn the heat pumps on. So they're still trying to utilize CO2 that's the most efficient. And when you try and explain to people, oh yeah, when CO2 gets into its transcritical stage, it becomes a lot less efficient. Yeah, but then you're getting really good high-grade heat out of it, which is now useful for heating. And it's trying to find that exact balance of where it's going to be most useful and where the right application actually is. And that's the fun part of it. There's no one-size-fits-all application. Having a bit of a joke with one of my other colleagues when I was still full, day-to-day designing, and he was very much, it's a copy and paste job, isn't it? They all look the same. You just take that design, change the name, put it again. And it's never, ever like that. There's 1,000 stores for Aldi in the UK, and not two of them are identical. And I imagine it's the same across the entire planet. No two systems are the same. No two systems will work exactly the same either. So it's using that engineering mindset to work out the best solution. That is engineering at the end of the day, is coming up with that best solution for that application. And that's what I love about it, even after 12 years.
Yeah, no, and I love that because this is what I love that you said, the engineer mindset, because it is important. It is a mindset, this refrigeration game. And as you continue to evolve yourself, there's so much growth in it and there's so much opportunity. And I got so much curiosity of where this industry is going, especially with CO2, all the different types of thermodynamics and all the new technologies that are coming in, because I'm hearing a lot of cool things that are coming into play, from solar stuff coming in with CO2, turbines, just different things that are happening out there trying to, keep the things cold by using less power. And all these people talking about, oh, CO2 uses so much energy here and this and that and warm climates. But I'm seeing some technology out there that is matching or even beating some HFC systems. So is it more advanced technology? Totally is. But you know what? As we evolve more, it's going to get easier and easier. Because back in the late 90s when CO2, it was difficult. CO2 is easy now compared to then when they didn't have any high pressure valve. They didn't have any controllers that could control it. Like, we're in a place that is so good for CO2, and it's coming. And this is why we have tons of CO2 training that we perform, and we do the CO2 Monday with experts just like yourself. So let's talk a little bit about that. You were designing systems at EPTA Group. What are some of the things that you learned? Because once again, you were a technician in the field. What are some of the things you learned, like some aha moments, like, wow, wish I would have known that when I was a technician in the field, and it just evolved through P&IDs, I'm sure, and through the design itself.
Yeah, I mean, just the general fundamentals of refrigeration. When you start introducing that transcritical cycle, and trying to get that into my brain, especially looking back at pH charts, because I hadn't really considered them since I was doing my apprenticeship just to get my qualification. Otherwise, it's just you put that, you do it for that, chuck it in the bin after you're done, and that's it. But no, once you're trying to explain transcritical operation to people and see no phase change happens, but you still got a really good temperature difference there, as long as your fluid you're heating is lower than that, great, it's still usable. But yeah, trying to get that across, and then think, but how do you then continue the cycle when you have a high pressure valve and that drops the line there, and then you enter your liquid receiver or your intermediate vessel and drop down there, but then where's that flash gas going, that takes it off there. So even though there's only two main components extra, your high pressure valve and your flash gas bypass, it makes it such a difference in your mind. But once you get to grips with it, going back now to a HFC or HFO system, that's what feels odd. Yeah. Like earlier today, I was explaining the pressure entropy diagram and the basic components in a heat pump application, but it's the exact same. I'm trying to think, actually, no, that's it. All I have to discuss. There is no flash gas bypass. There is no transcritical operation. I don't really need to put about critical point on a system because the refrigerants are never expected to get above that point anyway. But I do try and feed away into discussing CO2 in these applications, even though for example, these students at university probably won't encounter CO2 until they're experienced in industry, possibly dealing with heat pump or chiller manufacturers at that point. But if they know that and they've been introduced to it, they've already got a leg up above probably 90% of the engineering population who just are blind to it and they're not aware of it. It's only really retail, supermarket and industrial who've been exposed to it. I still have not arguments, debates with my own father on it, because he's very much of a mindset. The stuff he works on is still slightly too small scale for CO2. And he thinks, it's a waste of time, we'll go HFOs. I'm like, right solution for right application. You will work on CO2 eventually, or your engineers will at some point. Just wait, and we'll see.
And it's I've seen them in Coke machines, little tiny Coke machines. So they're in a super small, less than a kilowatt machines. So they're already out there. It's just when it becomes mainstream, and it is going to become mainstream. When did you start really training other people? Because I know you talk and you train, like you're saying today, like on CO2 and on HFOs. When were you always involved in training? Is it something you inspired to, or how did that develop? How did that evolution? Because this is what I talk about with a lot of end users, a lot of business owners. How can I get my lead technicians to help train and educate, pass that knowledge down? Because the knowledge is a little bit different now. Refrigeration knowledge, it's all the same, but when you go to an advanced system like a CO2 system, there's different knowledge. I'm seeing right now experienced technicians with quite a few years in it, learning at the same time as new people. You know what I mean? So how did you get into the training side of refrigeration?
So again, being from a really small company, as soon as we took a new apprentice on, they were out of everyone. You get banded from person to person. You try and stick them with a main engineer. But if you have a project where, for example, changing a compressor, a semi-hermetic bits of compressor, still not large scale, but you'd need two people to lift it, they'd be on that job with you. And as you go through, you tell them, no, okay, you got a front seat back valve or back seat back valve at X, Y, and Z. And I always really enjoyed that, because once you've shown someone and they do it for you, you feel that satisfaction that, it gives you a good feeling inside. And also it's a bit of an ego boost that, I know what I'm talking about because I can explain it to them. And it's always a bit of a selfish thing I found in terms of what it does for me as a person. It's got to be a passion. Yeah. But it always makes me feel like, okay, I'm the expert here, you've learned something from me, which means I'm the expert and I actually, hopefully know what I'm talking about. And then from there, through the years as training apprentices, that was always good. And then once I started the EPTA group, the training course I went on, it was only 2 days, but the way the engineer delivered the training was perfect. It was a day of theory, but it was at the right speed because there was me, I was there as a design engineer, not on the tools, but surrounded by 6 or 7 service technicians, or some of them really experienced, some of them with less experience on the tools than I had. So you had a really good range of people and you get the conversations going in the class. And I probably learned just as much about standard HFC systems as I did about CO₂ over those 2 days, because they've been exposed to stuff I never had. And it's just having that environment, that training environment. I always find if you don't learn something yourself whilst delivering that training, you probably haven't delivered it correctly. You need to have an environment where people are comfortable to speak up, share their own stories, and feed it back to you. And then, whilst at the EPTA group still, my manager at the time, he used to do the basic refrigeration training for the non-technical members of the company. So the call center staff, the accounts team, people in quotes departments, and all that sort of stuff, who would be exposed to the terms of compressor, evaporator, but not know what they are. We're lucky enough to have a warehouse on site with generally old, dilapidated coils if it was being refurbished or just ready to go to scrap. So we could have a bit of training, go down to warehouse, show them what they are. For example, with compressors, you show the people quoting the job, they're big, heavy compressors. You need 2 engineers for this. When an engineer says, 2 guys, 8 hours, you'll understand why. And not just thinking, I want a friend on the job with me. You need 2 engineers to get this done. And just having that, you'd get, I'd get 1 or 2 people afterwards come up and say, it was really helpful. And you think, even if you just reach 1 or 2 people, it's been worth it. It's always just really good fun. And then after I finished my degree, that was 2019, the course leader reached out, because they normally reach out to students who have just passed or just graduated to get them back and teach on a module or 2, because number 1, it's cheap labor. Number 2, they should know the material because they've just passed it. Didn't have the time available then to take it on, but the following year I did. So I took on probably far too many modules to teach, because alongside the design applications role, I then became manager, and then also took on this teaching. It was basic engineering principles, so really low level stuff, introduction to, for example, what enthalpy is, which was great because I hadn't covered that for 10 years. It was a good refresher for me. But also teaching mechanical services, which was the in-depth as much as I could make it at that point. Refrigeration cycle, air conditioning, so the properties of dry air, moisture, how that impacts heat, thermal transfer through different materials. Really what I consider proper engineering in the old school sense. That almost started to burn out eventually, because you're teaching, you're learning on the weekend to teach what you teach them the next day. You're still working 5 days a week as such. Plus then marking as well, marking people's work. I'm not a fan of that because it takes so long, but it's part of the job. And then as of September this year, I made the jump into consultancy, joined with James, Brian Churchyard and Nabil Cook, all fantastic people you've had on the podcast several times. They are the best of the best in the industry, in my opinion. And again, it's another chance for me to learn off other people. And also, as part of Amiga, we have a big proponent of training through the industry, where it's technical, non-technical. It could be management training. It's anything someone wants us to do. We will go away. Like I say, I'll have to go away and learn it. James, Brian, and Nabil have been doing it day in, day out for their entire careers. They know it off by heart, and they are the experts in the field. Which is the main reason I love working with them, is because every day, every time I speak to Nabil, for example, I learn 10 new things technical. And it just makes my brain explode.
I know.
It's fantastic. Training is the number 1 passion, I would say.
So what could be advice you could give? Because we got manufacturers on here, we got technicians, we got service managers. What advice could you give to them to help them be able to train or get the message across to their teams through training and development? Like what 1 or 2 tips that you could give someone about training, or a lead technician to help someone with their growth in CO₂ or refrigeration?
I'd say, the number 1 thing I think is if someone can shadow another engineer, and I mean, not just attend to help them on a site because they need 2 people for that specific task. Actually put them aside if even if it's just 1 day a month, if they can afford it, but just have someone shadow someone who is more specialist in that field, and get them to get them to really just sit down and explain every aspect of that job, whether it's a maintenance. For example, if someone wasn't a specialist on chillers, get them to go with a specialist chiller engineer, do a proper strip down, clean through, recommission, something like that. So you understand every aspect of that from start to finish, even if it takes several times. If you do it, if you physically do it yourself, you're not likely to forget again. And the other thing is literally just giving the time to people to train. As you said, about sometimes you have just got to upskill whenever you can. If it's an audio book, if I've got to a point now, sometimes if I know I've got a long car journey, I will find sometimes scientific papers, because you can tap the phone before you set off and set it to read out, and it will just read that throughout the journey. Sometimes it goes a bit odd and it cuts off.
Sometimes it's not right to talk about
Yeah.
I've done
Or
it
I'll
before.
read the time and date at the bottom of a publication on every page. But the more you can do, I mean, I'm now at that age in the UK where there are two main radio stations, and I'm just between the two demographics for each one. I'm too young for the older station, too old for younger station. So I figure I may as well listen to podcasts or audiobooks. I mean, hopefully in a few more years' time, I'll be old enough to listen to the older radio station again. But we'll see.
So I think that's the same thing. Like, I talk to all these service managers, manufacturers, like you got to get them on podcasts. You got to get them on technical talks, like Refrigeration Mentor. So many people have reached out and been like, this is perfect. I was just listening to, music that I heard, not garbage, but I just heard it 1,000 times. And now while I'm driving, I'm learning something. It could be an audiobook, whatever it is. This is how you develop yourself. And those who do it, I see them growing so much faster, just like you listening to technical paper. I want to get into something else and talking about education is like, and you said it earlier, how do you know when CO₂ is the right application? Because you said it earlier, we got to figure out, people need to know when CO₂ is right and when it's not right for a certain application, just like you talked about with your dad, right? He just didn't know, he doesn't know if it's the right application or not. But a lot of people, and we're talking about training, and I think this is huge because I don't think every refrigerant is for every application. It's dependent. You need more heat, less heat, more cooling, whatever it is. When do you know it's the correct application and why? Or just say a heat pump, we'll say. Well, let's just use heat pump to start off with.
Honestly, at the moment, at this moment in time, it's almost entirely down to client budget, I would say. Because you still pay a premium for CO₂ at the end of the day.
Yep.
And for example, a lot of our customers or supermarket retailers I've encountered, if they're going to refit their stores, they might have a refit where they need to rip out all their display cases as well. Perfect time for CO₂, because everything's going to be, you're going to be putting in new pipework regardless, or new electrical supplies. You're going to have space for that. Ideal application. Where you're only, say you have an island of chilled cases, you're unlikely to then rip out your packs and all your pipework and replace electrical just to upgrade that one system in a building. But then I've come across a few sites recently for another customer where they've got CO₂ subcritical and R134A high temperature packs, which those feed into. They are only about 8 years old and they're starting to deteriorate a bit, I think, from their location around. There's a lot of coastal works, coastal areas, which obviously degrade the kit quite quickly. But that might be a perfect case when they all eventually fail to upgrade to CO₂, because some of the infrastructure's there, and also some of the maintenance staff are already used to dealing with CO₂ in part of our site. For some of the smaller customers, for example, my dad looks after small convenience stores, you might only have 2 display cases linked to a condensing unit. Well, it'd be great to go CO₂ route with a CO₂ condensing unit, but when you're tendering that, you may be against someone who goes for a brand new HFO system, which may only be half a price. You're never going to win that. At which point, do you win the work, or do you try and promote environmentally friendly good engineering? So there's always that. Then there's also looking at the full life cost of the system. So I've done some studies, and HFO refrigerants are, they consume less electricity than CO₂ do. It's just part and parcel of where we are in the world in the UK. Environment, and when I say environmentally, I mean ambient conditions. As long as it doesn't leak out the system, it's going to be better for the environment than CO₂. But unfortunately, as we're all aware, systems leak. Despite best practice, you never have a site which is 0% leakage rate. But regardless, CO₂, if they do leak, even if CO₂ uses 20% more electricity, as our electricity grids decarbonize and we use more renewables, it doesn't matter how much electricity we use as such, because it's not impacting the environment. But if that refrigerant leaks, it still would. So it's all trying to juggle all these ideas, advise customers agnostically, these are the options, you make the decision. It's trying to come up with something which is simple to explain to them as well. Completely opposite of what I just explained, because that was the least clear explanation ever. But what I'm trying to get across is different applications.
Yeah, no, I like that, because even like when I work for the manufacturer or the contractor first, it was like, well, what's the upfront cost? But then when I work for the manufacturer and start to realize, well, what's the really lifetime value of that unit? And I've heard it too, like people here, I was at a bunch of different conferences where, oh, well, CO2 leaks way more than any supermarket that we ever seen for HFC. But you could leak probably 30, 40, 50% more, and it's still less of an impact than what HFC would be for, having one CO2 versus 1 pound of CO2 versus 1 pound of 404, which is like almost 4,000 global warming potential. So that means I can leak 4,000 pounds of CO2 before it equals each other. So CO2 is still not good for the environment. Like I do CO2 Mondays all the time. It's still GWP1. It's bad. You don't want to release it to the atmosphere. We're trying to stop these leaks. So I keep telling technicians, I talk to them, don't just blow it off. Like if you do need to blow some off, no problem. But you don't need to blow off a couple hundred pounds to isolate it properly. It's refrigeration. This is what we can do. You're going to isolate it correctly. And we're going to see more and more of that knowledge being out there. And people are going to get a better understanding of it over time, because I still don't believe people understand the total life cycle of equipment and the total cost. Yes, the electricity, like you said, the electricity cost may be more, but at the end of the day, is it going to cost less to the environment and to the bottom lines of those customers? And as technicians, a lot of technicians don't really, well, why does that matter to me, Trevor? Well, it matters by bringing value to your customers, I tell them. And when you can show the value of the equipment that you work on saves them money over a long term, they're going to be a customer for you. They're going to be calling you, the technician, all the time. They want you because they trust in you on providing that value and that knowledge, because they don't have that knowledge either.
Yeah. I mean, some of the sites, like when I was in my previous role tendering, heat pumps designed with some HFOs in mind. Okay, they're efficient in the heat pump, but the cost of that refrigerant is 30 times what the CO2 costs in equivalent. Plus, the pipe size is, you're looking at 4 1/8 pipe instead of inch and 5/8. It's considerable uplift then. It's all these extra valves, well, I mean, it's not extra valves, but the body physical size, it just blows out the water for installation costs. Yeah, it is the correct. It's looking at every single application individually. There is no blanket one. But also going back to leakage rates, CO2 doesn't leak any more across an estate than HFC did, because I've got data from a supermarket and their leakage rates, despite them phasing out HFC and phasing in CO2, leakage rates have stayed the same. So, I mean, maybe these are new systems and they shouldn't be leaking, but it's the case that it doesn't leak more, it leaks the same, which just, I think is, and
these leakage rates that I'm hearing at these conferences, I know for sure it's from reliefs at startup. Most of them are reliefs at startups, or someone didn't set something up properly, or there was an issue with the programming with it and it caused the high pressure valve to close or fully open and blow the receiver's relief, popped it off. And that's going to slow down, because people don't, I'm training technicians who have started up many stores and they've never been into a CO2 training. They're just like, they're just here. I was told to go there. I need to start it up. And this is what's happening out there. But as time goes on, as there's more knowledge, more people take the Refrigeration Mentor CO2 program and they get a handle on it, those leaks, those pop-offs are going to reduce more and more. And another big thing, I should ask you this, on the equipment that you guys installed out there when you were working at newer design, did you always add like an auxiliary unit to your systems? Because here in Canada, before you answer, here in Canada, the manufacturers here, some of them, it's mandatory. They don't sell systems without that auxiliary unit to keep the flash tank cool for service, or if the power not the power goes out, but the system goes down, or for some reason, auxiliary unit would turn on. Did you guys install those, or was that an option?
Never. In any of the applications I did fairly. The smaller scale supermarkets to the very biggest supermarkets. And from my experience, never, not once. If it insulation around these flash tanks is, it's a good inch thick, it's generally, they don't expect the system to be off for long enough for that to warm up. I think that's what they hope for. And if it does discharge, ideally it shouldn't bend the entire system. And if it does, there are enough wholesalers around to get enough CO2 back to site to recharge the system and replace pressure relief valves if need be. No, it's always risk reward aspect. I think they
I
decided that the
highly,
entire system's just not worth it.
everybody I talk to, I recommend getting an auxiliary unit. It's a peace of mind for technicians, a very inexpensive accessory. And like I said, a lot of manufacturers here in Canada, it's standard, comes with the unit. You're buying a $500,000 or $1,000,000 CO2 piece of equipment. What's another couple thousand? Not even a couple thousand. It's probably less, very, very inexpensive for the value you get out of it, because it's even that time. I've seen it where technicians have to do a job, say changing the oil separators, filters, or changing the liquid line filter dryer. Well, how much time do I have? And they're worried, and it's 110 out or 35, 40 C out. It's like you got less time in the middle of the summer than in the middle of the winter to work on it, right? Because it's warming up. So it's just a peace of mind, I say as well. So anyone who listen in North America, I highly recommend, if you're an end user, you should order an auxiliary unit. It's going to help out. I believe. Okay, so we dove into some training, which is awesome. We talked a little bit about CO2, why you need to go and you got to investigate with your customer what they really need at the end of the day. There's not one cookie cutter solution. It's just the world has changed. Like I know what manufacturers want. I want to just build this one product and works for everybody. It's just not the way it is. Even with HFO, like people are telling me, well, HFO equipment's way cheaper. Well, is it really cheaper? Because now you got leak mitigation. Now you got, now bypass. Now you got mechanical vents that you need. So nobody has really showed me the numbers yet, because there's a lot of add-ons to these new H2L refrigerants. And at least in North America, I'm pretty sure there as well. Like you can't just put an A2L without all these mitigation rules. So the price has come up for those as well with these new refrigerants. And I'm going to be interested. Have you ever dove into any of those numbers? Going from like, all this leak mitigation that you needed versus a CO2. Have you guys done any of those calculations yet?
So a lot of again, even with CO2, we tend to require leak detection systems for, warnings if it leaks into a space, if it's a centralized package system. Same with HFO, you now need them, but instead of for asphyxiation risk, it's now for flammability. But obviously that flammability, that lower flammability level is now the issue of HFOs in terms of system size, system capacity. There's only a certain amount of refrigerant you can add to that system, therefore how much capacity you're going to get with that system, until you now need two systems. And if you need two or even three systems versus a single CO2 system, that HFO setup is going to be more expensive to install than the CO2. The CO2 is smaller gauge pipe work. Well, not smaller gauge, sorry. Smaller diameter pipe work. It's going to be slightly quicker to braze in comparison, reduced installation time, reduced service route size effectively. There's going to be economies of scale. I think HFO probably a CO2 beat in the small scale singular condensing units linked to 2 or 3 display cases. But beyond that, gut feeling, I'd go CO2, but we've got to look at agnostically and look at what scenario, which refrigerant is best. I mean, it may be that it gets to a certain scale and ammonia should be being used in large distribution centers. But then in the UK, one of the largest chilled distribution centers in the entire country, if not Europe, is using CO2. So obviously, they definitely wouldn't have gone down that route unless it was financially viable, is all I can think. So.
Yeah, no, and I love that, because this is what I'm trying to talk with so many people around the globe is like, you got to assess what is needed. Is this a retrofit? Is this a new application? Is it warm? Is it by the ocean? Like there's just so many different things that come into play, right, on the equipment. And this is why when I do like project manager development and talks in like service teams or design teams, and talk to them about this, is just not one solution. You got to learn these other solutions. And this is where I'm seeing some people, just like consultants, just like you, continue to skyrocket in the industry because you're thinking outside the box, all these different solutions instead of just, oh, well, it's just this one solution that we have. Well, no, there's a lot of other things you need to think about. And then once again, do you have the technical skills that somebody can come and work on this equipment? Because that's important as well. They need to be trained. If they're not trained, it's going to cost more money for the end user. At the end of the day, that's hands down how it is. If you don't have that skill level to work on it, you're going to have to get someone from outside the area to come in and work on the equipment.
Yeah.
So we talked about training. We talked about some of the service. Now you're working with Omega Solutions, with really good friends of mine. I love those guys there. How's your transition into the consulting work? Because you did it all now. You did the technician, the service role, install. You did the application engineering and the engineering design. Now you're into consulting. And so how's that transition? Because I know a lot of technicians out there, they want to continue to evolve. Like they love being a technician in the field, but sometimes you got kids, You know what I mean? You're getting the mid 30s, mid 40s. You want to change because it's, working sometimes 12 hours a day, or just you want that change. What is that evolution for you now going into the consultant side? And how's that been for you?
It's a complete different lifestyle is all I can say. It's nice because no matter where you are contracting or manufacturer, you've got to push effectively your company's line in terms of equipment or solution. That's how it is. It's how business works. But as a consultant, you're acting as the client's agent in our case. You is literally your job to come up with the best solution, regardless of what option it is. That option's best for this scenario. We go down that route. You're expected to know all the legislative requirements and regulations, what the industry is like on the ground. Is there a skill set there to work on this equipment? If not, what can be done about it? It just opens your world so much more, I find. It's freeing. It feels like more back to engineering rather than cost management and project management, which I sort of drifted towards. I'm not great at it. Yeah, I know my skills. I know what I enjoy, and project management is not it. I'll do it if need be. But yeah, going back to consultancy, it's project management, but in a different sense. You're not the one getting phone calls at 8, 9, 10 p.m. on a Sunday because some pumps haven't arrived on the supermarket. At which point, it's down to you to go and, I've got some pumps in my garage. I'll bring them to site. It's a 2-hour drive. I'll get there, fit them, come back, and no one's any the wiser. That's the ideal thing. If you've done something right, no one knows you've done anything at all in that sense. Consultancies, just a completely different world. You're the expert. No one's second guessing every demand you make or any comment you make, because no one thinks there's an agenda behind it, because there isn't. The only agenda is what's best for your customer, which is what it should be throughout any aspect. But it just feels easier in that sense, I would say. Like, don't get me wrong, there's difficult days, there's long days, and
yeah.
Your head is spinning sometimes, but it's a different type of busy. You're not constantly firefighting, I think, is the main thing. You can almost plan ahead and think, okay, I'm going to focus on this, and I'm going to get this done, I'm going to give this my all, and I haven't got to juggle 10 other projects at the same time where they're all completing on the same day, they're all commissioning at the same time. We've got 10 sites and we need 3 commissioning engineers. What's going to happen there? It's a lovely scenario, and you learn so much more about different aspects and more involved with other manufacturers. And to be fair, it's opened my eyes to the options which are out there. I mean, going back to equipment, how suitable it is and scale, many of the what you consider air conditioning manufacturers are now moving into CO₂ condensing units, and some of them are absolutely fantastic on energy performance and have really wide operating ranges as well, all sort of down from 3 kilowatts up to 18 to 26, all on the same system. So it is usable for all those applications. I think that will make a massive difference in the market. So it should bring the cost down considerably, and also generally their alarm parameters and their controllers give you a lot more information about, it's a fault code. It tells you exactly what's wrong, rather than you having to dig around in an RDM system to figure out which is it working on air on or air off now. It should simplify the process, hopefully streamline the process for technicians, and actually just help everyone on site. So it should be an exciting time over the next couple of years as they're introduced to the market.
Yeah, it totally is. I'm super excited about it. And I really enjoyed this conversation because I learned a lot from you, Chris. We've only met once in person. We'll see each other again. Our final question is a 3-part question, is because you've been a technician and engineer in the field, you've been a designer, now you're a consultant. What is one tip that you can give each of them? One tip you could give a technician, one tip for someone working as a manufacturer and application engineering, as well as somebody who's coming into the consulting world. What's like one tip that you could give them in regards of CO₂?
I'd say don't be scared to ask questions is probably the main one. Put your ego aside, and just, even if someone talks down to you almost, as long as you're getting the answer from them, who cares? That's the main thing. If in doubt, ask. And if you don't know anyone who does know, nobody probably does, in which case, have a go safely.
Yeah.
It's all I can think of, really. Is that's in every aspect, whether that's on the tools designing it, on the tools fixing something, or in the office designing. You've all got to adhere to health and safety and work safely, whether it's for you on site or designing systems for other people to work on safely. But yeah, keep an open mind, ask lots of questions, pester everyone you can, and hope you learn something from it.
Yeah. No, I love it. It's so true. Just got to ask those questions, because a lot of people are scared to ask the question. Just ask the question. The worst that could happen is they don't give you an answer, or they even criticize you, well, then just take it and just go ask somebody else. You know what I mean? Like that's about it. Like this is how I'm learning. There's lots of people said that's a dumb question, Trevor. I'm like, yeah, it was, but I asked it. Now I know. You know what I mean? And that's how you grow. And then if they don't know, like you said, go ask someone. Chris, I want to thank you so much for taking the time to chat with us, share some of your knowledge and some of your history. I know we'll have many more talks again. I'll have you on the show again. Any final words?
No, just thank you for having me, Trevor. And again, look forward to seeing you either once you're back over in the UK or if I'm in the USA, well, Canada,
Awesome.
any point. My wife would love to go to Canada, so hopefully we can tie in a trip and I can make it a business trip then as well.
Yeah, let's do it. Let's
But,
do it. I love it.
Thank you so much for having me, Trevor. It's been a delight.
Awesome, Chris. Thank you so much. And everyone, thanks for taking the time to listen and take some of the things that Chris said and think about it. Ask those questions, get involved in training and education, teaching other people. This is what I do. This is what Refrigeration Mentor does all the time in all our programs. I'm teaching things all the time and I'm learning about all these new technologies, all these controllers that I'm learning about, all the design that I'm learning. Someone's teaching me and I'm teaching it to other people. But what I'm doing is I'm taking the action. I'm going out to these sites. I'm watching technicians pump down systems. I'm watching them set up controls so I can learn. And this is what you guys need to do out there as a technician. Or if you're a designer and engineer, get out to the field. If you're in the office just writing those CAD drawings and you never go out to see what's happening as a technician and what they're doing in the field, you're missing so much. You're missing so much. And this is when I'm training these manufacturers. I see it all the time where they're not out in the field. They don't know what's really happening out there. They just see it on paper. You got to go touch it. You got to go feel it. Just like Chris said earlier today. Once again, share this with other people. Like this is how Refrigeration Mentor podcast grows. And if you enjoyed it, like it, share it, post it. And once again, I'll see you next week at CO₂ Mondays and let's get a conversation going.